we're trying to accomplish here is a fusion. So we want the best material between those two pieces of bone.
Advanced material science really is truly push the boundaries of what we can do from a design standpoint and from a manufacturing standpoint.
The three tenets of surface, structure, and imaging are not mutually exclusive, though they've been treated that way in the past. If you don't appropriately balance structural integrity with radiolucency, or you sacrifice stiffness for surface topology, you won't win.
It's a mindset and a philosophy for us to take what we've learned from nature and from our various experiences and utilize technology to transform the typical properties of implant materials.
Advancements in software and 3D printing capabilities have allowed us to create implants and designs that we never would have thought possible.
I think one of the huge mistakes that a lot of spine implant companies are making right now, they took their peak designs and made them out of titanium, and we're talking about a completely different material.
What we were setting out to do was figuring out a way to go beyond the implant just being a structural element inside the intervertebral space to now being able to contribute to active healing.
Porosity is very essential. We've shown in our preclinical animal models that porosity really drives bone ingrowth. It has the highest integration strength with the bone compared to non-porous traditional implants.
How can we take a biocompatible material like titanium, effectively reduce its stiffness, improve its radiolucency, but maintain its natural mechanical integrity?
It all comes down to the implant optimization process. When you look at the Modulus implant, each strut, each detail on that implant has been optimized.
We've finally gotten to the point now with Modulus where we've again solved all those problems that regular titanium has. One of the things that I really like about this a lot is that lattice structure.
The main body lattice of Modulus was designed in a way to ensure that it was fully porous and the strength of it was fully optimized for the requirements of an interbody device.
Clinically, I think our fusion rates are going to be great. I think our subsidence rate is going to be very low. And when we image, we're going to be able to see, and I've got lots of CT scans and MRI scans, and you can see around this cage very nicely because the total volume of titanium is very, very low.
I'd say this is only the very beginning. There's many future iterations and evolutions of the Modulus platform that are going to give us the ability to take the manufacturing technologies out there, the increases and improvements in design, and really take it to the next level in terms of generating positive results for the patients across the world.